Activity diagram. Activity diagrams are something like the famous flowcharts, but much more powerful. Activity diagrams can show much more than the usual step, decisions, and loops that you can find in flowcharts. Therefore, they are useful for describing processes to a broad audience. Its purpose is to enable analysts to present a concrete, easy-to-follow visual of the workflow of a business use case. When used for software modeling, activities typically represent a behavior invoked as a result of a method call. When used for business modeling, activities may be triggered by external events or internal events. Here's a simple example of an activity diagram where I mapped just the activities of the login use case of the ATM. Look at it for a few seconds, and I bet you can figure it out all by yourself. The most commonly used elements of an activity diagram are: a simple piece of behavior is called an action. An action cannot be further decomposed into smaller actions. You show an action in the UML notation as a rounded rectangle. Place the name of the simple behavior as text inside the rounded rectangle. You can even explain more complicated action by putting some pseudocode inside the rounded rectangle of the action. An initial node is the starting point for an activity. An initial node can have no incoming edges. Activities may have more than one initial node. In this case, invoking the activity starts with multiple flows at each initial node. Activity final nodes terminate the entire activity. Any execution in any other node is terminated without results. You can have multiple activity final nodes in a single activity diagram. Still, hitting any of them terminates the whole activity. Show final activity as a solid circle with a border around it. A decision node uses a test to ensure that an object or control flow goes down only one path. You indicate a decision node with a diamond shape. Use this node to construct an if-then-else selection or switch statement for an execution path. Each decision node has one input edge and multiple outgoing edges. When data arrives at the decision node, a single outgoing edge is selected according to the evaluation of a guard condition, and the control is sent along that edge. A merge node is the opposite of a decision node. You bring separate decision paths back together with a merge node. The merge node uses the same diamond shape as a decision node, but a merge node has multiple incoming edges and a single outgoing edge. Finally, sometimes you need activities or actions to work in parallel. To split behavior into concurrent operations, you can use the fork node. All forks are followed by a merge to indicate the end of the conditional behavior started by that branch. The merge of the parallel activities must be combined by a join. The initial fork and the latter join are represented by the same symbol, a fork.